Here we will draw the basal motor circuitry. First, let's establish the major involved structures. Begin with the cerebral cortex. Its relevant input is from the thalamus, and its relevant motor output is to the cranial and spinal motor neurons. Motor impulses enter the basal ganglia through the putamen and exit through the combined globus pallidus interna and substantia nigra reticulata nuclei. To draw the circuitry of the direct pathway, first show the putamen inhibit the combined globus pallidus interna substantia nigra reticulata nuclei, and then show this nuclear combination inhibit the thalamus. Imagine that these two inhibitory pathways cancel one another out. Next, show that the rest of the fiber projections are excitatory, those from the cerebral cortex to the putamen, from the thalamus back to the cerebral cortex, and from the cerebral cortex out to the motor neurons. Label this entire circuit as the direct pathway. Overall, then, the direct pathway is an excitatory pathway. Next, we will draw the indirect pathway, which incorporates several of the same steps as the direct pathway. Both begin with corticostriatal excitation of the putamen and end with globus pallidus interna substantia nigra reticulata inhibition of the thalamus. For the moment, think about the indirect pathway as being just like the direct pathway, with the only addition of passage through the globus pallidus externa, which adds an additional inhibitory step. Because this creates 3 inhibitory steps in a row, the sum of the pathway is inhibitory. Let's draw out the indirect pathway. First, show the putamen inhibit the globus pallidus externa. Then show the globus pallidus externa inhibit the globus pallidus interna substantia nigra reticulata combination. This is the simplest version of the indirect pathway. For completeness, however, we need to add the subthalamic nucleus, because some of the fibers in the indirect pathway loop through it, and when it is injured, patients develop wild ballistic flinging movements called balismus on the side contralateral to the subthalamic nucleus lesion. Disruption of the indirect pathway here causes overexcitation. Show the globus pallidus externa inhibit the subthalamic nucleus, and show the subthalamic nucleus excite the globus pallidus interna substantia nigra reticulata combination. This separate loop does not alter the arithmetic of the indirect pathway. There are still 3 inhibitory steps, which make it ultimately an inhibitory pathway. Lastly, we need to account for the substantia nigra compacta, because Parkinson's disease results from a loss of dopaminergic cells within the substantia nigra compacta. The substantia nigra compacta serves to energize movement. It excites the direct pathway and inhibits the indirect pathway through the different dopaminergic receptors in the putamen. Indicate the dopamine 1 and 5 receptors, which are excitatory. Show that substantia nigra activation of these receptors causes excitation of the direct pathway and thus excitation of the excitatory loop. Then label the dopamine 2 through 4 receptors, which are inhibitory. Show that substantia nigra compacta activation of these produces inhibition of the indirect pathway and thus inhibition of the inhibitory loop. In short, the substantia nigra compacta acts on both pathways to generate the same ultimate effect, the promotion of movement. This concludes our drawing of the basal motor circuitry.